Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop an application that will generate music from text prompt or description. So we are going to utilize Meta's Audiocraft library and we will develop a Streamlit application where the end user will give some prompt, basically the text description, and then the application will generate the music, okay, with the help of music gen model. That's what we are going to do in this video, so let's quickly do it. So if you see here, I am on my folder. I will go inside desktop and music gen. I have a folder called Audiocraft and I'm going to open this in VS Code. So let me just open this in VS Code. Okay, code dot, and you can see that I'm in this VS Code. Okay, let me just remove this, by the way. Okay, so I'm going to write all my code here, which is required to develop this application. We're going to develop a simple Streamlit app where the end user will submit the prompt and will use music gen to generate the music. Okay, so if you are not familiar with Audiocraft, okay, Audiocraft, just write GitHub or something, Meta, and you will get it. Okay, so it's not a new library. The library is a little old, and I have a video on Audiocraft as well, but they have now open source almost everything within Audiocraft. They have a model called music gen that help you can see it over here, that helps generate music based on natural language description. Okay, that's what we're gonna utilize. And you can see we have music gen, a state-of-the-art controllable text to music model, and they also have text to sound model. Now we have Tortoise TTS, we have Bark by Suno AI, and we have now Audio Gen, for example. And there are others as well. We're talking about open source model there, guys. So now they have open sourced it, the entire training code, and of course the inference code is there. So we're gonna use this music gen small model. It has 4 different type of model weights. We're gonna utilize the small model and run it in as quickly as possible, just to show you the capability of this model. Okay, so I'm gonna come over here and maybe I'll also show you something, okay, because you'll have this question that how did we so let me see whether, okay, now you have to do a couple of things. You have to clone that Audiocraft GitHub repository, and you can see I have already cloned it here. You can see Audiocraft, all the files which is in this folder. You only have to keep this Audiocraft folder. You can delete everything apart from it if you want to delete, okay, but if you want to read it, if you want to also try the Gradio app and something else, you can also try that, but I'm gonna have a very minimalistic approach, a very simple application, and we'll write our code quickly, and then we'll just try it out, okay, in a very simple way, okay, because it's a little complex to set this up, but we will do it. So this is what you have to do. You have to git clone that, go inside Audiocraft, pip install -e, and dot means in the same directory you are. So basically it will install it. I will not recommend this approach, by the way, because it says, okay, you have to use Python version less than 3.8 or 3.7. I don't recommend this way of installing the requirements. Okay, rather you install it, see what are the dependencies. I'll give the requirement.txt on the GitHub repository that you can follow along, okay, and install it. Let me just create an app.py here. Okay, I just need app.py, and I'm just going to do that. So let's use that. So the first thing, of course, right, we have to access the model file. So I'm going to do Audiocraft and .models, because if you go inside Audiocraft here, you'll find a models folder for sure. You can see this is a models folder. If you go inside this model folder, they will have something called music gen. So that's what I'm going to write here. You can see, right? So let me just show you quickly. You can see this music gen.py. Okay, now if you click on music gen.py, okay, you can see this is the class I'm going to use, class music gen. Music gen main model with convenient generation high level APIs or something, right? So they have different checkpoints from Hugging Face, and we're gonna use music gen small, which is around 350 MB if I'm not wrong, or something like that. Okay, I might have forgot the exact number of the model weight size, but that's what it is. Okay, so we're gonna utilize this music gen.py file and then high level API in this code. So from audiocraft.models import music gen. We're gonna build a Streamlit application. So let me just do import Streamlit as st. I don't know why I have given a gap here, by the way. Okay, let me just do. Let's also have OS. It's required. I mean, we need torch. We need torch audio. We need torch audio torch. Okay, we are good. Import torch. We also need numpy, so import numpy as np, and we're gonna need base64 to save the file or to download that audio file through through Streamlit app. Okay, so we need base64, and here we go. So that was a good timing. Okay, now let's write a load model function here. So what I'm going to do, I'm just going to write, okay, load model, and I'm just going to use model equals the same checkpoint. If you come over here in musicgen.py, you will see this small Facebook whatever, right? So I'm just going to use it like this. This is how we load a model, musicgen dot from pre-trained. It's not from, it's get pre-trained. Okay, get pre-trained, that's the function, by the way. Get pre-trained, and just the model name. So it's by Facebook Meta. You can find it on the Hugging Face as well. And I'm gonna use musicgen small. If you have high compute power, I'll recommend you go with musicgen melody. Okay, if you have that, that's a very good model. And I'm not using that because not everybody like has a GPU or that VRAM to inference this. So return model. Now this will give us the model. As we are going to build a Streamlit application, I will straight away cache this, guys. So in the runtime, I don't have to load the model again and again. So let's do cache resource from a cost standpoint. So we're optimizing our cost if you are deploying this in production. So st.cache resource, load model. This function basically loads the model, guys, right? Pretty much simple thing over here. Okay. Now define load model, musicgen, and get pre-trained. So now what I'm gonna do next? Maybe we can, or should we write the function, or should we write the Streamlit thing? So let's write the Streamlit thing. So import Streamlit. So maybe you can write def main. I'm gonna write. Let's write pass for now. And I don't know why I activated this. Just give me a moment. Okay. I'm gonna use if name equals main. That's it. And here I'm going to write all my Streamlit logic. So let me just do one thing. I'm gonna say title, and my title will be text to music generation. This is my app title, by the way, text to music generation. Or we can also do one thing. Let me just do set page config. Let's set some page configuration. Okay, and here we're gonna pass page icon. We're gonna use a emoji, guys, later. Okay, page title or something. For now, let's write musicgen or something. Okay, this is okay. Let me open something called GitHub emojis music, and I'll I don't know. Let me do a control F quickly, search for music, and yeah, but I need music. So music, and I'll just take this for now. Let's see if it's able to. Through Markdown, it should support. I don't know. I will check it out. Okay, so musicgen. If it doesn't support, then we'll copy the actual emoji. Title. Now what I also need is let's have an expander, just to put a line there, that what are we doing with this. So with expander, let's call it about app or something, or let's call it C explanation or something. Okay, C explanation. And now here we can write write 1 or 2 lines about the app. This is a music generation app built using Meta's Audiocraft library, and it uses let me do an alt G. It uses music gen model or something. Okay, music gen model. Okay, based on your natural language description. Based on your natural language. Excuse me. Based on your natural language description, it can generate music. that's it. And you can use this, guys, a lot of use cases, to be honest. You can use it for your YouTube video or channel also. I don't know, maybe we have to look at the copyrights. I don't think that, I think it's a good way of, generating some unique music based on your creativity, or if you are a music fan, you can generate a lot of music and you can use that in your video. If you look at the YouTube again policies, and then you can decide. But I think you can do that, if I'm not wrong. And what I'm gonna do here is, let's have a text area where the end user will put their prompt, natural language description, or just a description for generating that music. What I'm gonna say, ht.text area, and here I'm gonna write enter your something. Okay, enter your description. So let's probably do that. Enter your description is fine. Okay, enter your description and there let's also have a time slider, guys. So let's have a slider that will help end user decide how long of a audio they want, or the music they want rather. Okay, so let's end user decide that. So when I use a slider here, so let me just do ht.slider, and here I'm gonna say, okay, I need a slider, and in this slider I'm gonna say select time duration or something. So select time duration, and let's write it in seconds. And here what I'm gonna say, my minimum time, you can see the function def slider is showing minimum value, maximum value, and the value, okay, where it should be by default. So I will have minimum value as 1 second, 1 second of audio, or let's call it 2 seconds of audio. That should be the minimum. And your default should be 5 seconds, and let's keep a maximum of 15 or 20. Let's keep it 20 seconds, right? But it will take little time, but it's fine. Now these are the input that we need from the end user, guys. Apart from that, we don't need anything else. And now let's do one thing. Okay, let's now call it if text area and time slider both is present, both there's a value inside or something, right? You can now let's print that htdoc.json, and let's have a key value pair inside it, and say your description or something. Yeah, and then it will be text area, and then your description, then selected duration, time duration or something, selected time duration. So why should we have time as, let's make it this one, and let's also use in seconds or something, in seconds. Okay, time slider, that's it. So this prints the some information to the end user, that what is the input that they have asked for, or what are the description that they have fit to the model or the large language, like the model, the music gen model. Okay, now what next I'm gonna do, let's have a subheader first. Okay, to say, okay, that ht.subheader, and inside this subheader I'm gonna write generated music or something. Okay, generated music, that's it. Okay, generated music. And now let's run this, guys. So it looks nice, we have loaded a model, and fine. Okay, let's come here. We are in Audiocraft. Okay, let me activate my LangChain environment, LangChain, and just gonna do streamlit run app.py quickly. Streamlit run app.py, and what I'm doing here is, I'm just running a file. You can see it's running here on the right hand side on top. You can see we have got some UI over there. Okay, text to music generation, see explanation, where you have an explanation. This is a music generation app built using Meta's Audiocraft library. It uses music gen model. Based on your natural language description, it can generate a music. Now here you can write something. Let me just write something. Okay, excuse me, I don't know why, just give me a moment. It's fine. Okay, main max, and then I think it's the value. Okay, so it's wrong. So mean value, max value, and the value by default when it's loaded the screen, when it loads the screen. Now I'll just do a rerun. You will see that the slider will be at 5. Perfect. And let me write something. Classical Bollywood mix with a little bit of with little jazz, something like this. Okay, if I'm putting this as my prompt, and now you can see it's like this, your description and selected time duration in seconds. Okay, fantastic. Okay, and then we have generated music, right? So now we're gonna write the code, guys, for generated music, and that's what we're gonna do here. So if you see, this is my main function, and I'm gonna write all my code up, like whatever function that we need here, after def load model. So let's just do that. So the first thing that we have to do, you have to write a couple of functions quickly. So okay, let's first write generate, let's call this music tensors. It's gonna be a torch tensor because it decodes that. I'll show you what I'm talking. Okay, so generate music tensors, and it should take your description, and then it's also should take your duration. So let's call this as an int, some kind of validation. Okay, our duration is int. Now we're gonna write something here. So the first thing is, let's also print to track this in terminal, guys. So I'm gonna just print my description here, and description. I don't know why it said plus. I'll just gonna give, excuse me. Then we have print description, description. Let me just, okay, and also print duration here, guys. So duration. That's it. Okay, so we are printing it. Now let's load the model that we have defined the function on top. Now here we are loading the model. Now the first thing that we have to set some parameters, right? So we have been working with large language models nowadays, like a lot, and the lot of hyperparameter and a lot of inference parameters. That depends if you are training or inferencing it. So here we are inferencing, so we're gonna set some inference parameters. So set generation params, yes, set generation params, and within this params I'm gonna use sampling. Okay, and I want this use sampling to be true, and you can find this entire thing in the musicgen.py. So use sampling true. Let's have top k as well. So top k, and for now let's have a around 250, and then I'm gonna use duration, like how long the music should be, and this will be duration. It's the end user will be deciding through slider. This slider is basically nothing but your duration, guys, here. Okay, so now the model is there, model set generation params. I'm gonna have an output here and say okay, output, and in this output I'm gonna generate. So I'm gonna use generate function from that musicgen.py file or the musicgen class. So model.generate, and in this I'm gonna pass my description first. So description, and it can be a list also, you can pass multiple descriptions. So I'm gonna use this in a list. So let's call it descriptions, and then progress, let's have progress equals to true. If you want to show that in a terminal or a Jupyter notebook, you can keep that progress equal to true, and let's do return tokens equals true as well. Okay, cool. Now what we're gonna do here is, let me just have an output. Okay, output is already done. So what it does, guys, this output basically holds the tensor value, the torch tensor. Okay, so what I'm gonna just do, I'm just gonna return this output and the first one, and you can pass multiple, right? So you would have multiple as well. That will basically arrays at the torch tensors that we have. So here we only need the first, so output inside list, passing that 0, return output. So what this function is, okay, now we have written this function. Now we need one more function, because now we are getting the tensors, and we have to basically, this is basically the tensors of decoded audio samples. So you have that audio sample, we then perform some decoding stage, and then this all tensors are basically of the decoded audio samples. Now let's write one more function, and we're gonna call this function, for example, save underscore audio here. So let me just do that, save underscore audio, and in this save audio I'm gonna write samples, and my samples are nothing. I'm gonna use torch dot tensor. So let me just write tensor, and here we go, and here we're gonna use our audio, like save audio. Okay, so let me just do that. I'll just save audio. Okay, the first thing that we have to do, we have to basically set some, like we have to set some configuration values, or we have to like sample rate and where are we going to save this or save this audio. So what I'm going to do here is I'm going to first write a sample rate. Let's have 32,000, the standard sample rate, and this is a recommended sample rate, guys, for music music generation. So sample rate, I'm gonna write 32,000 here, 32,000, and now after sample rate, we're gonna write where we're gonna save this. So let's have a save path as well, and we're gonna save it in. Let's create a folder here first. Okay, so let me just create a folder. I'm gonna create a folder called audio underscore output. Okay, so we're gonna save our audio output in this path, audio underscore output, and let's keep that restricted to this folder, save path. This is okay. Now let's use assertion. So assert and samples, assert samples dot dimensions. So we're gonna use dimensions. So excuse me, dimensions is equal to and or samples dimension 3 stereo mono. Okay, oh, samples, let's see. Okay, let's check that. Okay, samples dimensions equal 3. Okay, now this is an assert. Now what I'm gonna do here, samples equals as samples dot so we have CPU, so samples dot detach. I'm not getting that detach. Detach is a function. Okay, CPU is we can use it. Okay, fine, looks good. Okay, samples. Now now we're gonna check, we're gonna put some conditions. If dimension is 2 or 3, so for if sample dimensions, if samples dimensions equal yes 2, this is okay. Now here what we're gonna say, just say samples equals samples none, samples and none, and that's it. So samples. Now we're gonna say for excuse me, I don't know why it becomes capital, for IDX index audio in enumerate. Okay, samples, this is right, this is correct. Excuse me guys, I don't know why it's just opening here. Okay, we just go on to for IDX audio in enumerate sample. We're gonna put that in audio path. So let's have a variable called audio path, and in this audio path we're gonna join this. This is right, save path, and then file, and then audio and underscore right. We're gonna give this, you can use that IDX, perfectly fine. IDX dot wav, let's store this in a wav format. Okay, and let's close this parenthesis here. Now this is okay. Now let's use torch audio to save that file. So torch audio dot save. I'm gonna pass my audio path, I'm gonna pass my audio, and I'm also gonna pass my sample rate. Okay, so this is for saving that audio file, and this is okay. Now what else we need? We need one more function, because so far this will save that in this here in this audio output. Now we need one more function, so let's write that function quickly guys, and it's a simple function. So basically we'll let end user download this file. So def, let's call it get binary or something. So get binary file, get binary file download or something. Okay, now let's write downloader HTML. Okay, such a big function name. Get binary file downloader HTML, and I'm gonna write bin file. Okay, the bin file, the binary file. So bin file. Okay, and then we have file label. So bin file and then file label. So let me see, bin file, file label, and this file label we can assign it as a file. This looks good. Okay, now here we're gonna write our function guys for this get binary file downloader HTML. So let's open that. So with open file label, no, it's not file, it should be bin file. I don't know, such a bad recommendation. Bin file, So with open bin file, excuse me, as f, fine, with open bin file, okay, right, as f read data, f dot read, perfect, f dot read. Let's come out of that with, and I'm gonna use a string, so binary string, and I'm gonna use base64 to encode this. So b64 encode, where does it go? Anyway, b64 encode, b64 encode, and let's pass our data inside this, and then let's just do a decode. I don't know if we don't have to do UTF-8. Okay, it's okay. So binary string. Now we're gonna use markdown in Streamlit to download this file. So you have to write href f and maybe through an href. It's not HTTP, so we don't have any hosted thing. So it should be data application. Perfect. We need octet stream. So this is the right suggestion. So data application octet stream, and we're gonna pass a base64, perfectly fine. And here I'm gonna pass bin string. So let's pass bin string. Actually, I don't know why I said okay. Binary string, and then after this, this is okay. Binary string, and I don't know what I am missing here. We have to close this href. Okay. Now after this, we're gonna write download. Okay, now download will be again OS path or something that we have to write, os.path.base name, maybe os.path.base name. Yes, let me just do an alt G, base name, and we're gonna pass the bin file here. Okay, so bin file, and inside the bin file, it's okay. We are okay with it, guys. Maybe we can, so let's close this first, the download here. So download gets closed, and I'm gonna use here download or something. Excuse me, this is with this download. Okay, so this becomes download. So now what it will do, it will download the file, but we can also give a file label. So download, and now what here we can do, we can write this file label that we have, perfectly fine, and we are done with this, guys. So just return the href. Now this href, we can use it within an Streamlit app to download the file, which is octet stream, which is audio in this file. So return href. Okay, fine, return href. That's it. We are okay with this, guys. Now what we're gonna do, we're gonna just run this, Streamlit application after utilizing this function that we have written. So after subheader, we have to write a few things. So what I'm gonna do, subheader. Now let's write a variable called music tensors. So music tensors are nothing but we're gonna use that function generate music tensor, the function that we have defined on top, and we're gonna pass text area, and it also takes the time slider. So let's pass time slider. Now the next line that we are gonna use is, let's print that, by the way. So let's print it, and we're gonna track this. So we're gonna say music tensors. Okay, and I'm just gonna write music tensors. Okay. Now music tensors. Now you're gonna file save music file or something, variable, save music file, save underscore audio, the other function, and here I'm gonna pass music tensor. Once we see, okay, there is a tensors inside, let's pass that tensors, because that save audio function is looking for something called torch.tensor, which is your sample. That's what we are passing here. Now save music file. Now we're gonna have audio file path. So let's just do audio file path, and here in audio file path, I'm gonna give this file path, which is audio output. That's it. Okay, so and we also know that what file it's gonna save, because we have defined that on top. So audio underscore 0, that's an index that we have, and that WAV. Okay, so we can define it. It will overwrite all of your audio. So maybe you can change this logic. You have to change this logic, because you will have multiple prompts if you are building an application where you are passing multiple natural language descriptions inside that list. So it will generate multiple basically the audios for it, which is the music. So you have to change this logic of how you're gonna save this, the naming convention and all. So for here we're just generating a single file, so it's okay for now. So audio file path, and let's call audio file, by the way. We're gonna we have to read that. Okay, so we're gonna use open here, audio file path, and just gonna read that. Okay, so just use this audio file. I'm gonna have audio bytes now, so let's call it audio bytes, and bytes are nothing but audio file dot read function in. Okay, now we have this audio bytes. We can use st.audio simply. So let's use st.audio bytes, and just gonna use st.markdown here, guys. So st.markdown, and in this markdown I'm gonna write get binary file downloader HTML, and within this you're gonna pass audio file path. You're gonna have to pass the path, and let's call it audio or some label, just a label. So you click on that label to download. And if you have written a markdown thingy, so you have to do unsafe allow HTML equals to true in streamlit. Here we go. I think we are done with the app, guys. Okay, so now we have written all of our code. Let me quickly explain what we are doing. Now we have, first clone the Audiocraft GitHub repository. Audiocraft, an open source music toolkit library by Meta. Thank you, Meta, so much for whatever you are doing for open source community. Now we have cloned that, and we have written few functions. The first is to load the model, music gen is small. The second is to generate the music tensors by setting up some inference parameters, and then we using model.generate, and then just returning the torch tensors. Now the save audio, which look for the torch tensor from the above function, we have put we are just defining some configuration like sample rate, as sort looking at the dimensions, and then we have just saving that audio with some index and all, and then we have get binary file downloader, pretty much simple thing for Streamlit, using base 64 and all, octet stream, and then we have just utilizing that function on top within the Streamlit app. Now here we go. Now let's run this app, guys. We have to run this app, so let's run it. Okay, so I'm just gonna do a refresh first. Okay, and I will keep a 10 seconds of audio, and I'm gonna write a classical Bollywood mix with jazz and electro. Let's call it electro mix. Let's remove this mix. Classical Bollywood style with jazz, and let's click outside, or you can do control enter to run it. Now this will take time, guys. Okay, this will take time. So let me pause the video. It takes up to 30 to 45 seconds. I'll pause the video and I'll come back once it's generated. Okay, and you can see that we have got our music. It says generated music, a classic Bollywood style with jazz and electro mix. And we have got our music here. You can see. Let me just download first. Once I download, you can see all the downloaded. We'll see that. This is fantastic. I don't know if you can hear this, but this is really amazing. Okay, I'll just go to this one. So we generated this music. You can see you can also download this. You have download audio, and you click on this download audio, it download this. Now you can use this in one of your YouTube video background, or wherever you want to use, right? In some PowerPoint presentation, some product video, wherever, right? So now let's try something else as well, guys. So what I'm gonna try here is maybe a guitar, an electric guitar based hip hop music or something like this. Let's make it shorter, 8 seconds, and then see now what it does. So now you got the idea, right? So you can play with the prompt, and you can probably bring your creativity. I'm very bad at music, but if you have interest, you can extend this app further. You have text to video generation with Runway Gen 2, and a lot of other, even with images, people are using Control Net, After Effects, etc. To create smaller videos, and you can maybe create a commercial, right? An ad, and that's what Coca-Cola does recently. They have created an entire ad and commercial, I think, with generative AI. You can also do that. You have text to music, text to images are like Mid Journey, for example, stable diffusion. You go ahead and create those arts, and if you also use Runway Gen 2 and combine that all together, right? You have deep fakes that I don't recommend, but there's Roop, there's a lot of other services. So what I'm saying is that you can create an entire music video or an entire demo or video or trailer or teaser or whatever with artificial intelligence or with Gen AI nowadays, right? We're calling it. So I can see I'm running this on CPU. I do have a GPU machine, but I'm running this on CPU to see. But it takes around 45 to depends, right? It has a number of steps, so it takes around 45 to 60 seconds. Up to 10 seconds of music generation, and fantastic. I really love the quality of music, to be honest. Now if I just play on this, you can see a guitar based pick of music. There is some noise. There is a bit of noise. The previous one was better, but that's I will not complain about this. I really liked it, the way it's generating the music. We can use this music but of course, please give credit or source citation. We can only give it to Meta now. For now, we don't know if Meta is giving to the people who have created the data set, or the people of whose recordings we are using, and of course there will be some open source data set as well. So that's all for this video, guys. I wanted to create a simple text to music generator app using Audiocraft. I have one video on Audiocraft. It was when it was newly launched few weeks ago. But now I wanted to use music gen model to basically create a text to music generator app, and I hope you like that. The code will be available on the GitHub repository. Please go ahead and fork the repository or clone the repository and extend it further. Let me know if you have any thoughts, feedback, or questions. Please drop that in the comment box. I'd like to answer it. Maybe you can also reach out to me through my social channels on the YouTube banner. That's all for this video, guys. If you haven't subscribed the channel yet, do subscribe it and share the video and the channel to your friends and peers. Thank you so much for watching. See you in the next one.